Okay, so in this video, I'm going to be talking about lambdas in Java. So let's get started without further ado. So first thing, uh, I want to use an example, okay? An example that I want to use is the map function from JavaScript. So if you're familiar with the map function in JavaScript, this is going to be very intuitive. If you're not, that's fine. We're going to be going over it, so nothing to worry. The first thing, let's create an array, uh, a list of integers. And it's going to be like, okay, 1 through 6. Let's import these classes. Great. What is wrong? It's undefined. Oh, okay. So now let's say we want to get another list, but instead of 1, 2, 3, 4, 5, 6, we want 1 squared, 2 squared, 3 squared, 4 squared, etc. So whatever is in nums, we want another array with the elements of nums squared. So let's do that just imperatively in plain Java code. So what that looks like is squared nums, new array list, and then take each element in nums and add it here, right? I can't type, okay. So this is simple enough. This is just plain Java code, right? And of course it works. So now let's abstract this a little bit. So instead of doing all this here, let's make a method for it. Okay, so this is still pretty intuitive what's going on, right? Instead of doing it in the main method, I just made another method for it. And of course, this also works. So now let's say we wanted more of these, right? We don't just want to square nums, we also want to cube nums. We want to do other things with each element. So we would need to make new methods for that, right? So square nums, just make one more. Let's say we want to do cube nums, then we just need to change the name here and add another one of these. Uh, let's say now we want to do some other function, then we need to make another method. So you see how there's a lot of repetition here. This is going to bloat our code for no reason at all, right? The only thing that we're really changing here is this. So to avoid all this repetition, we could use lambdas. So before we use lambdas, let's make a function called map. And this returns an integer, a list of integers, and it's also static. Map takes in a list of integers, and it takes in so I didn't make this yet, I'm just typing stuff, but it takes in an object of type func. So func is actually going to be an interface. Okay. So what this does, so I'm just writing it out, sort of like envisioning how this will look without actually creating the func interface yet. So what will this look like? So this is going to be the same as before. So this is the key part in what's inside of res.add, right? Because that's what we need to change every time we make a new one of those functions. So instead of having e times e or whatever, we do f.apply e. So now we know what the func interface should look like. So this has one. Oops. So I'm just doing this in the same file, which is bad. Like usually you would use more than one file to do this, but this is so that you can see everything. So let's get rid of this. So func will have one abstract function which returns a parameter of type v and takes in parameter type u. So this is generics. And if you don't know how generics work, you should probably just learn about that before this. So now you see there's no compilation errors anymore, right? Everything makes sense. But the actual implementation is still pretty weird. So let's say we didn't know about lambdas. This is what it would look like. So let's say we want to get squared nums, map nums, and then here, let's say we had a class square, let's call it square num, implements func, and then this is going to be integer input, integer output. And that's, by the way, that's what the U and V stand for. U is the input type, V is the output type. So here we will we'll define the apply function, or we'll fill in its method body. Yeah, so integer apply, integer U, variable, the name doesn't matter, obviously. Okay, so this is just plain object-oriented programming, implementing an interface. So here we'll pass in new square node, right? We should print this. So let's see what's happening. Right, it works, but this is still pretty annoying. Every time we want a function, we have to define a new class. That's even worse than what we had before, right? Before we had methods, now we're doing classes. There's a better way to do this. So instead of creating a class, you could use anonymous classes. So now, instead of doing square num, we say new func. And to be extra clear, I'll even define the types. And so this is the syntax for anonymous classes. If you don't know, you say new and then the name of the interface. You don't need this, but I'm just doing it. And then here you fill in the abstract method. So in this case, there's only one. Yeah, so here you just return u times u. So this works. Great. So now we don't have to worry about naming our class when we're implementing the interface. We don't have to worry about any of that, right? But this is still a bit verbose. So we can cut this down now using lambdas. So instead of saying all of this, we could use lambdas. So the number one rule when using lambdas is that the interface that you're using to create the lambda has to be a functional interface. So what that means is that the interface has to have one abstract method. That's it. Okay. So if you had more than one here, you can't use lambdas. You can still use anonymous classes. You can't use lambdas. So that's pretty much the rule. So here, instead of, I'll do it down here so you can see the parallels. I'll call it square roots 2. And instead of doing all this, integer I, so use this arrow. So return item. So as you can see, square number is 2. So this works as well. And this and this are the exact same thing, right? The implementation, like under the hood, this and this are the same thing. This just gets converted into this, right? So the lambda is actually an anonymous class which implements a functional interface. So that's what it does. And now that you know that, I'll get rid of this. So turns out that you can make this even more concise. So, oh, and by the way, so the reason that you need a functional interface for this, for lambdas, is because what you're doing with lambda is you're filling in an abstract method from the interface. So if you have more than one method in here, more than one abstract method, then the compiler wouldn't know which method to fill in. So if there's only one, then of course that's the one you're going to be filling in. So that's why you need a functional interface for Lambdas. So as I was saying earlier, you don't need to do a lot of this actually. Be very concise. You can get rid of the brackets and the return to make it look like that. So that's already looking pretty concise, but you can make it even more concise. That's it. That's all you need. And here you can define whatever you want. So I'll print, um, instead of assigning it to a variable, I'll just print it directly and show you. So you can do a bunch of these. I times I times I times 4. And do like, whatever. I'll just do this. I or 2 to the I. And then I'll cast this to it. And there you go. All these different functions, you didn't have to do any work besides actually just fill in that apply function. So this is how you could avoid a lot of repetition. You can see how we didn't even need to write much code at all, right? We only need to write what we need to write. So that's basically Lambdas. And yeah, hope you found this helpful.